What is going on, guys? So today we're going to take a little bit of a break from welding, from exhaust, from doing the window regulators on the X5 because I don't feel like doing them today. I know that's what our next video was supposed to be, but you know what? I don't think it's going to be. So what I wanted to let you guys know is that aside from fabricating exhaust systems and everything else, we do a multitude of other products, including catch cans, fuel tanks, all kinds of stuff like that out of aluminum. We also do stainless tanks, titanium tanks, you name it. You need it, you give me the measurements, I'll make it. What we're going to be doing today is we actually have a set of, I believe these are Hasport swap mounts for a Honda Civic. Now, these are super popular. Hasport and Innovative are probably the two biggest manufacturers of these, and they come with urethane inserts. Now, if you want a little bit extra or a little bit less movement in your engine, making a set of solid inserts that fit into these mounts is going to be the key. Now, you can buy them online and everything else, but the problem is both Hasport and Innovative, these mounts are very inconsistent when it comes to inner diameter size, and the reason being is that they basically thread. I don't know if you'll be able to see that inside. It's not really threading per se, but it is like a knurling on the inside that is designed to hold on to the urethane mounts. Now, urethane mounts having give, you can slide them in, push on them, and they'll stay. Well, what we do is we actually make a custom aluminum insert, and these are not them, but it just show you something what it's gonna look like. We make a custom aluminum insert that does fit into these mounts here. They match basically the size of the inside of the mount. So if you guys are interested in purchasing these before we actually get into the video of making them, there are two ways that you can purchase these mounts from me. Now, the mounts are $150. Let me just, there we go. The mounts are 150 bucks, and that includes 6 pucks to cover 3 mounts. That would be driver's side mount, trans mount, and rear mount. So $150, all 6 mounts. Now, the two ways that you can actually buy these from me. The first way is to actually box up these mounts, send them to me, and I will manufacture the inserts that fit your mount specifically with just a 1 thou press fit. So I'll have them all pressed in for you, ready to go. Send them back, you pop them in your car, off you go. The second way that you can do it is take something like this, a digital caliper or an analog caliper or whatever it may be, and take a measurement of the inner diameter of every single mount. And I want you to do it this way, and then flip the mount 90 degrees and take it this way, because there is an inconsistency with these mounts. So the worst thing I'd have, hate to have happen is you guys get your set of mounts and you go to put them in and they don't fit, which I've had happen before. So measure all 3 mounts, give me the measurements of all 3 mounts, label them accordingly, front mount, left mount, rear mount, whatever it may be, and I can actually whip up some mounts for you. I'll have them all marked out and ready to go. So what we're going to do today is we have this set of mounts here for a friend of ours. We're going to go ahead and turn these up on the lathe. We'll fit them perfectly to this particular mount. And then we also have the other mounts that we're going to fit everything up to. So what I'm going to do is I'm going to make the inserts for just this mount and show you guys that, so I can show you how they're made. And then you can kind of get an idea of how the rest of it goes. Alright guys, so what we need to start out doing is we need to take 2 measurements. We need to take an inside diameter measurement of this particular piece, which I believe is going to be about 2,360 or so, 2,344. We're going to get an initial cut diameter, 2,344. You can see it right there. And then we're going to measure the outer of this, because we want to not go bigger than the outside diameter of this. So we're looking at 2.833. Yeah, 2.8. We can go 2.85. Make it a little bit easier on ourselves here. All right, so we'll go 2.85 outside diameter. And then inside diameter, going to be 2.36-ish, somewhere around there. And I got gloves on, so I can't see what I'm filming. I hope it looks good. There we go, we'll just use my nose. All right, so now we're going to measure this, and we're going to see what we need to take off of it. We're at 3.2 So we need to take roughly a half an inch, get ourselves down to 2.85 or 2.850, which is 2 inches 850 thousandths, just over 2 3/4 of an inch. And we'll set you guys up. We'll knock that down to that size, and then we'll start cutting our first piece. I wish I could zoom this a little bit better for you guys, but maybe we'll do that in post because we are recording at 4K, so I can blow it up a little bit. But we're going to cut our initial down to 2.85 inches, and then we're going to go ahead and we're going to drill a 1/2 inch hole right through the middle of it. The 1/2 inch hole is going to be for the through bolt for the motor mount. So I like to get my initial done first, and then we'll go back and we'll center drill, and then we'll drill, you know, the rest of the 1/2 inch hole all the way through, and we'll be good to go. So we're going to go ahead right now and turn this down to 2.85 inches. We're probably going to take 50 thou at a time, which will be 100 thou in overall diameter. So whatever you're taking off of one side, you're also taking off the other side. So if you're taking 50 thou here, you're taking 50 thou here, and ultimately it's 100 thousandths off. That's one thing it's a little tough to get used to when you first start using a lathe, is that all of your measurements that you run in on your cross slide is going to be double what you're actually running in. So we'll start here by you know, just kind of get an idea of where this is run out wise is going to be. We'll come in, we'll just touch it, and then we're going to dial in 50 thousandths. We'll see how that cuts. Alright, so we went ahead and bit off a little bit more than we could chew at that point. We're moving a little too quick. We're still running 50 thou. So we'll basically have to do this 5 times to get our 500 thousandths off. But we're running it in auto feed, so it's auto feeding itself all the way down. I'm sure you guys can probably see that spinning. The hand wheel down here is rotating and taking off little by little. We may actually go ahead and speed this up a little bit too, just so you guys aren't having to wait so damn long. So let me do that real quick. Alright guys, so now we got our initial cut done, and I'm sure you can see it's pretty rough, pretty nasty. So what we're going to do is we're going to go ahead and we're actually going to take another 50 thou off, which in all reality is 100 thousandths. So we're going, right now we're 100 thousandths less than where we were at. We're going to go 3 more times, which will be 400 thousandths total. Then we're going to take a measurement, and from that measurement we'll be able to determine where our final cut needs to be, and then we can start drilling our hole. Okay, so we're going to go ahead and measure this. We did take off everything that we needed, and just keep in mind, for all you machinists that are out there that are watching, I'm not a machinist. I just play one on YouTube. So hold your comments, hold your screaming at me. All of my inserts are shot. I need new ones. And again, I'm not a machinist, but we can get things done here. So counting for heat expansion and everything else, we are at 2854, which is pretty much about where we want to be. We wanted to be at 2850. We're at 2853. So what I'm going to do is what they call a spring cut, and that will take care of that little few thousandths there. So we'll speed things up a little bit. Turn this back on. and we will knock out just a little cut, a couple thousandths. And that's just to clean up the material, get rid of any burrs that we did, because we were doing pretty heavy cuts, and this machine is not really the biggest machine in the world, and it's not really something that's designed to be cutting material this big, so kind of got a bunch of stuff working against us here, but we make it work. Alright guys, so we got a really nice finish on that now. Gave it a cut. Let's give it a measure. See where we're at. And we're perfect. 2.850, which is exactly what we were shooting for. We got that. So now what we're going to do is we're going to actually take our live center, move it back. We're going to throw a drill chuck in there. We'll put a center drill in. We'll go ahead and we'll center drill this, and then we'll bore the 1/2 inch hole through the middle of it. Okay, so I wanted to show you something before we do this. This is what's called a center drill. Now, a center drill is basically just a rigid, very small drill bit, and it is stepped. So you have an initial size to get your center bore, and then it shoots a little bit bigger so that we can go ahead and use this guy. Now, the problem is why we don't just use this right off the start is that when you're holding it back here, it's going to want to do this as it starts to drill, and our hole is not going to be exactly centered. So we go ahead, we hit it with this center drill as a pilot, then we send this drill bit through. Alright, that takes care of the pilot. Now we'll stick the 1/2 inch bit in there and we'll blow through it. Alright, we'll try to get you guys an angle that works for both you and me. And now we're going to go ahead and drill this thing. All right, so now that we got the 1/2 inch hole drilled in it, what we're going to do is we're going to go ahead and put our live center back. Now we're going to turn down the inside diameter for the actual mount, and what we're going to do is we're going to measure the depth that we need to go with this cut so that we can get a depth for the actual mount itself. And all we're going to do is we're actually going to take the mount, and there's a shelf down here. We're going to measure down to the shelf, and that'll give us the measurement that we need from the top here to the shelf. That'll give us our thickness for our insert. All right, guys, so that measurement is about 933 thousandths. Now, what we're going to do is you got to remember aluminum expands significantly when it gets warm. So what we're going to do is we're going to cut it down to about 850 thousandths, which will give us just under 100 thou. Or actually, you know what? We'll go to 833 or 834. That'll give us 100 thousandths of expansion capability with these mounts inside, because the last thing you want is for these mounts to heat up, expand, and start to push themselves out of the actual mount itself. So we're going to take this, we're going to come over here, and we will mark where we're going. And then what I like to do is, you know, not being the best machinist in the world, staying at Holiday Inn Expresses a lot, is I come in with my cutter, and we'll turn on the lathe, and we'll make a nice little mark at that 833. All right, and then we'll measure twice and cut once, because, you know, that's how you're supposed to do it. And we'll see where we're at. We're at about 800, 810. So we're going to go a little bit past our mark we made, not too much farther. This measurement isn't ultra critical. If it's too small, it's no problem. It's if it's too large that we're going to have an issue. So now we're going to cut this section down to our inner diameter, which our inner diameter that we're going to be shooting for, rough estimate, is right at about 2,360. So if we can go down to 2,360, we'll be good. So 2,360, and we're currently at 835, so we need to go 825.25. So we need to take, we'll start with 500 thousandths. And we're going to do this in smaller increments so that the cuts come out a little bit better. But yeah, we're going to take about a 1/2 inch off of this right now, and we'll see where we go from there. All right, now we'll take a measurement halfway through. It's always good to keep measuring as you're going along, because the last thing you want to do is overshoot and then have to scrap the part that you're working on. That's never fun. So let's take a measurement and see where we're at. All right, so we're at 2,500 roughly. We need to go to 360, so we need to take 140 off. So we'll go 100. See where we end up. Okay, so we took 100. We want to be at 360. We're at 392. So now 390, we want to be at 360. We're going to take 30 thou off of it. Remember, 360s are rough, so we're going to go 5, 10, 15. Alright, so we'll measure again. As we start getting closer, this gets more and more important, and we're at 362. And always give yourself a thou or two for expansion, because right now this thing is actually pretty hot. So we're in the ballpark. We'll measure our part again. And we're at 357, 358, 360. So now what we're going to do is we're going to throw a little bit of a chamfer on the edge of this thing here in a way that nobody's going to like. We're going to use a file to lay just a quick chamfer on this. And then we're going to do our first fit test. We're going to pull the tailstock out of the way, which makes a lot of noise. Pull our tailstock out. And then we're going to move our cross slide back. And we're going to take our mount and we're going to see what kind of fitment we got. And man, we are close. We are very close. We could probably take 4 or 5 thou off of that, which is not much at all. And we'll see how fitment goes. Just remember, guys, this is still hot, so it's expanded a little bit. You don't want to go too far. You're literally going to take a little spring cut. Sometimes just leaving this thing right there and doing a little spring cut like that will give us exactly what we need. So there we go. We got fit on that side. We got fit on that side, and as soon as our expansion goes down, these will jump and fit all the way in. And if not, we can give them a slight little tap, just a nice little 1 thou press fit, and we're good. So now what we want to do is measure that final diameter as of right now. And we are at 2.352. And that's going to be pretty much our overall diameter for every one of these that we make. And like I said, we'll hit this with a little sandpaper. We'll clean this up, make this face look nice. And once this cools off, everything's going to fit perfectly. So now the next step, we put our chamfer on. We got everything in here pretty decent. Now we're going to come in here with our cutoff tool. We're going to cut this off, but we need to take the measurement of how thick our flange is going to be on the outside. Now, typically, these are about 250 thousandths, which is roughly what the other mounts are, but I like to kick them down just a little bit. So we go down to about 2.25, and that's where our flange is going to be. Now we're going to go ahead and switch tools on the lathe. We're going to make sure we got enough distance here, which I don't think we do. Actually, we might. We'll stick that on there and see what happens. We may just run this out just a hair. All right, so now we will bring all of this stuff over. We'll get our mark. Get just on the outside of our mark here. We're good there. Now we're going to lock the slide down so that it doesn't move. We're going to bring our tailstock back in. Get that nice and tightened up. This will avoid any weird vibration because this machine was built in the 40s. Tighten all that stuff up, and now we can cut this part off. Alright guys, so here we go. We got our insert. Now, my bits are chewing this aluminum up a little bit, so that finish isn't great, but we're going to sand that down. We're going to make it look super pretty. They fit perfectly in. And we have that last little bit there where we're actually going to have a nice little press fit so that these don't move around. And we are literally fitting good. And you can tell that you're fitting good is if this thing won't go in sideways until you tap it a little bit, and then it just drops right in. So we have that little bit of press fit at the back that'll press right in there. We'll make the other one. We'll do the exact same thing. So we're good to go. We're going to do 5 more of those. Hopefully it won't take as long. And we'll be done. Alright guys, so that does it for the actual mount inserts. Now, again, if you're a machinist, please don't crucify me. I know I'm not a machinist. I know I do a bunch of stuff wrong. But this is what we do here to get our stuff done in a timely fashion, and we've not had a problem yet. So, leave Brittany alone. These inserts, just so you guys are aware, if you think they're cool, they are cool. But when you put them in your car, especially your daily driver and your street car, you are going to rattle the teeth right out of your head. So if you're building a race car, if you're building a really high performance, high power street car, these are for you. If you want these just to look cool in your daily driver, you are going to hate yourself for putting these in. So with that being said, if you're into them, again, they're 150 bucks. Hit me up, Instagram, DM me, email me, call the shop, whatever it might be, and we can get you guys set up with a set of these mounts. They do greatly improve stability with the engine. I've seen them not break axles as much because there's not a whole lot of windup in the engine, and everything is planted with these mounts. So again, just be wary. They are going to make your car a rattle box if it's not already. But yeah, so hope you guys enjoyed that video. I had a good time making it. I hope some of you machinists out there catch a good laugh. But in the end, we're making stuff, and we're making it happen. So hit me up if you want them, and I will see you guys on the next video.